There, today we are doing day 2 of solving linear quadratic systems. Okay, so we have a warm up here. I'm going to skip down to the bottom part. It says we can follow the same steps as we did previously. Remember, that's day 1. The only difference is that we will need to x factor today to get our x values. Okay, so let's go to the next page. Backside. Okay, so what I'm going to do first is see, okay, I both have a y equals on both of them. So that means that this half is equal to this half. I can just substitute it in over here. However you want to think about it. All right, let's erase those yellows so we can see better. Okay, so I'm going to plug in 7x plus 1 right up here. So that's equal to x squared plus 5x minus 7. I need everything on one side, so it's equal to 0. So minus 7x from the x's, and then minus 1 from the number part. Okay, so that just canceled, that just canceled. Now I have 0 equals x squared. 5 minus 7 is negative 2x, and then minus 8. Okay, so now at this point, I have an A, B, and C value. Some of you are probably thinking, oh, I could quad formula. You can. I'm going to show you how to factor, though, because that might be a little faster. So I have first times last, so negative 8x squared over negative 2x. I got to figure out what multiplies to get negative 8, but adds up to get to 2. All right, so 2 and 4 should work, 2x and 4x. And the bigger number needs to be negative because my bottom one's negative. Okay, so remember our trick. When there's a 1 in front of x squared, I can go straight from my factors to my factored form. So watch, I have x plus 2 and x minus 4. So remember my 2 goes here, my negative 4 goes here. All right, that's still equal to 0. You can put the 0, here, or you can say equals on this side. Doesn't matter. All right, now I need to set them equal to 0. So x plus 2 equals 0. Solve that mini equation. So x is equal to negative 2. Solve this mini equation. X is equal to 4. Okay, so those are the first part of both of our answers. I'm going to write them out like this right now. That's our first part. This is our second part. I need the y value for both of them, though. So what I'm doing is I'm looking at my linear equation. That one's easier, so we use that one. So I'm going to rewrite it over here. Y equals 7x plus 1. I'm plugging in my x value, which is negative 2, in for x right here. Okay, so I have y equals 7 times negative 2 plus 1. So negative 14 plus 1 is negative 13. All right, then I'm going to plug in 4 for x. So I have y equals 7 times 4 plus 1. Okay, so 28 plus 1 is 29. So again, the reason why we need to do this algebraically sometimes is that these numbers really don't fit on a graph very nicely, and that just sounds like a headache to graph. Okay, so let's try one more. The only difference from yesterday to today is that we are x factoring now to get our answers. Okay, so let's do one more. Again, I'm plugging in this part here is equal to y. So it says that right there. Okay, so I have 2x minus 3 and equal to my right side. So I have x squared minus 3x plus 1. Remember, pause this if you're thinking I'm going too fast. You can rewind and rewatch anything that is confusing to you. So I want to get one side equal to 0. So subtract 2x from both sides. And we'll do it at the same time. I'm going to add 3 as well. Do the opposite. So that also cancels. Okay, so I have 0 equals x squared minus 5x plus 4. All right, again, I have this trinomial, so I'm going to try to x factor it. First times last. So I have 4x squared, negative 5x. All right, figure out which two numbers multiply to get positive 4, but add up to get negative 5. I have 1x and I have 4x. Both of them will be negative. Okay, so then I look at my equation. My number in front is that invisible 1, so I can do my shortcut. I can go straight from my factors to my factored form. So I have x minus 1 times x minus 4 is equal to 0. Okay, now set up your mini equations. So x minus 1 equals 0. I will add 1 to both sides. And then x minus 4 equals 0. Add 4. Okay, so those are the two x values. I'm going to write them over here. So I have 1 and 4. I'm going to plug them in, like you said, to my linear equation, which is y equals 2x minus 3. Okay, so I'm going to plug in 1 for x in the x spot. So I have y equals 2 times 1 minus 3. That's negative 1. Then I'll plug in 4 for x, so y equals 2 times 4. So 8 minus 3 is 5. All right, these are my two solutions to this problem. If I were to graph it, say right here, I have some sort of line like this, some sort of quadratic, and it's hitting at 2 spots. These are the 2 spots. We found them algebraically instead of graphically. Okay, and that is it for today. Nice job.